Students, here's a story problem where we're asked to apply a comparison between pressure and volume. So it's just going to be a matter of using Boyle's law, but they embed the question within a story. They tell us a balloon is only designed to be inflated to a volume of 2.5 liters, and we fill the balloon with 1.8 liters of a gas. They say helium, but the exact type of gas won't matter, at sea level, and is released and rises to an altitude at which the atmospheric pressure is only 492 millimeters of mercury. Of course, that's less than sea level. And we get to assume that temperature is constant. Well, let's list out some things. We're going to solve for the volume of that balloon at the lower pressure. So initially we had filled the balloon at sea level. That would be in keeping with our pressure unit that they gave us, 760 millimeters of mercury. The volume initially was 1.8 liters. The new pressure, 492 millimeters of mercury. And the new volume is what we're going to solve for. And then once we solve for that, we'll ask ourselves, is that bigger or smaller than 2.5 liters? So long as the pressure units are the same, you do not need to convert into atmospheres. And you might say, but why do I need throughout the gas law problems to convert temperature into Kelvin but not pressure units or volume units into a particular type of unit? And that's because for pressure and volume conversions, you multiply or divide rather than add to do the conversion. That means that the proportionality is maintained. Now, with pressure and volume, it's an inverse relationship. So Boyle's law has us multiply pressure and volume initially, and pressure and volume at the end. We'll solve for that final volume. And in this case, it works out to be 2.78 liters. So that answers the follow-up question, which is, what's the volume of the balloon at the higher altitude? 2.78. And then to answer the initial question, well, they say that the manufacturer says it can only inflate to 2.5 liters, and 2.78 is bigger than 2.5, so that thing's gonna burst, sucker.